So let's start with some of the searching and sorting techniques in C++. So, so we're going to learn some searching techniques. So there are mainly two types of searching techniques. The first one is linear search, second one is binary search. And in sorting techniques we have two sorts, that is the bubble sort and the selection sort. So let's just see what is meant by the searching and sorting in general. So searching refers to finding whether a data item is present in the set of items or not. For example, we want to find a number and a list is given. So what we do is that we take the particular number and we search for the number in the list. If it is present, we get a successful message that the number is present in the list at a particular position. That position factor is it's not necessary, but in some programs we may need to tell the user that this element is found at this position. Giving more information about anything is useful. Same way, if you tell more information about the position, more information about the element, then it's good. Then we go to the next point, that is sorting refers to the arrangement of data in a particular order. So we just discussed about searching. Now let's discuss about what is meant by sorting. Now sorting refers to arranging the data elements of a list or an array in a particular fashion. It can be arranging in ascending order, it can be arranging in descending order. It depends on the user's choice. Mostly it depends. Sometimes this may be a predetermined factor. So the person making the program may arrange the list in a sorted order. Maybe he wants to arrange the elements in ascending order. It's his wish. So then searching and sorting have many applications in the area of programming. Yes, it is one of the most important it's one of the most important things used while making programs useful for the society. User dependent programs mainly. So let's go to the first part of the search. We saw that's linear search. So linear search is applied on a set of items that are not arranged in any particular fashion. Okay, for example, if we are given an unsorted array, a group of elements, okay, we are given a list in which numbers are haphazardly arranged. They aren't having any kind of pattern. So in this case, we use the linear search. So in this, the search process starts from the first element. The searching is continued till either the element is found or it is not. If it's not found, we'll get an unsuccessful error message. So let's see how it works by taking an example. This is just an algorithm. If you see, so we've been given a list. It's not having a particular order, so we have to search for 75. So what the compiler basically does in linear search is that we take the element which we have to search. We compare that with each element of the list. Just look at my cursor, how I'm doing it. Take 75, you have 75. Take 75, compare it with each element of the list. If it finds the element at a particular position, it displays that the search was successful or the item is found. That is a cout statement, so it can be anything, and we can tell the position of the element as well, which is going to be i+1. You'll see that. So what it does in the first step, it compares 75 is equals to 58. No, is it true? No, it's not true. It's going to return 0 for the 0 answer for this particular evaluation. Then the second one, is equals to 75 is equal to 62? No way. 75 equals 75, it's coming true. The termination of the program. The program terminates at this point. There is no further checking gonna take place after this. So let's go to the next slide. So it's the second example. You can just have a look at this. It doesn't explain anything big here. It's gonna be the same thing. Compare 41 with 58, 62, 75, 88, 92, and 105. We see that this element is not present here. So when the element is not present, the compiler has to check for each and every occurrence. That means the compiler has to check the element with every other element in the list. Okay. Then at last it says if it's not found, it's our wish, we can display not found. In that case, we cannot display any position as well. So let's see how we're gonna write a program in C++ to by using linear search to implement linear search. So I just skip the hash include. I use stream using namespace std, all the stuff. So let's go through the program. I'll just explain you the logic of the program, because my main aim is not help you in coding. My main aim is to, there are many coding channels in YouTube. I need not start another one. I'll just tell you about how the program works, so you can understand, you can get a better feel of programming. Some people just mock up code. That's not at all good practice. It's not going to take you anywhere. So first line is declaration. We'll see it at last. Always just leave, while programming, it's a good practice to leave a line for a declaration. You just start writing whatever you want. You declare variables on the go, and at the end, don't forget to declare the variables at the beginning. That's the best way, because at first it's very difficult for us to declare the variables. We miss out some as well. So it's better to keep on using your variables, declaring at this point, and then do the declaration at this point. Use them here without declaring them. Before compiling, declare them. So you ask the user for the elements. So the number of elements are stored in this variable n. Then we go for a loop. We know how to enter elements into an array. We're not doing a list here, it's an array. What we're doing here, because we are searching for a number. For I equal to 0, I less than n, I plus plus. This means that starting from position A0, go till the number less than n. Okay? We're incrementing it. That's what the loop means. Hope you know the basics of loops, of how to enter elements in an array and how to display elements from an array. Then we ask the user which element he wants to be searched for. So that is stored in the key variable. Then we go for the next loop. And what does this loop mean? This is the main loop. This is the main loop of this linear search program, because till here you can do whatever you want. You just need to get the array done, and you just need to get the element to be stored in an array, in a variable. So here, this part of the program is the main segment of the program. Okay, if you get this right, you need not worry at all. So what we do here is that to start a loop, what we do is that we compare each element of the array with the key. That's what we were doing in the example, if you remember. We compare each element of the array with the number 75. We compare each element with 75. When we get 75, we just terminate the program. The same thing is going to happen here, if you see. So for I equal to 0, I less than I plus plus, whenever something is happening with the array, we have to start with the loop. So we compare each element with the key. If it's found, we say found equals 1 and break. So what happens is that if it's found equals to 1, okay, found is signed with number 1, and we write the break command here. So what happens is that when we write the break command, it turns out of the loop at that moment without doing any further things, because otherwise what happens is that it checks for each occurrence. Even after finding the element, it may check to the last element, which is not necessary, which may take up more CPU time. So what it does is that it compares each element with the key, and if it's found, we break at that point. We come out of the loop, we come out of the for loop, we go to the if statement. That means if element is found, that means found is equal to 1. In this case, when AI equal to key, we write element is found. Else we write element is not found. You're on with the program. That's what is done in linear search. Okay? Hope you like the video, because I don't want to make this very big. I don't want to do the binary search at this point. You can just try this code if you want on your C++ compiler, on CodeBlocks, or any other compiler editor that you use, IDE. You can also use Turbo C++ if you want, but I don't recommend using that. It's like a crap compiler. I don't like this. I don't like that IDE as well. So hope you like this. See you next time. Bye.